Again, if you feel that you don't need this review and you'd rather just talk, feel free to go out in the hall. I only want those people who truly are interested in becoming smarter. We're done. There's nothing to kid about. Eli.
Number 7, I don't understand why it's not 1, 3, 5, and 7.
We'll get to those when we get to the how to do questions.
But what was the answer?
0, 2, 4, and 6. I was 7 the first 12 times I read that answer. We'll get to that. Don't worry, Eli. We'll answer all of your questions. Will be answered, children. That is my job. Because Eli can't wait, let's do the 2, 4, 6.
Hey.
Yeah.
I know it was easy, I just don't understand how I got it wrong.
Alright.
I got 1, 3, 5, and 7.
Me too.
Yeah.
How?
Why is that not?
Eli, how? I got 0, 2, 4.
Because you multiply 2 by 1.
Eli, 1 minus 1 is 0.
Yes, I thought it was 2 times 1 minus 1. Isn't that what it is?
Yeah, 2 times 1. No, Eli. It's 1 minus 1.
Yeah, I know, but.
So
Oh, you did parentheses first. Oh, right, okay.
Times 2 times 0.
Even I got that.
Okay, right.
Yeah,
We don't need to do that.
Don't steal my thunder. Now I'm gonna have to explain all of that again. Number 7, because Eli wanted to know I was too busy messing with the board. A rule for sequences is A sub n. Remember, n is always the number of the term you're looking for.
Okay, sure.
Easy, that's recorded. That was Eli, by the way. Those of you listening to this, Eli was getting a little frustrated. N is the hashtag of the term, number of the term. So you have this formula, a to the n equals 2 times n minus 1. They wanted the first 4 terms. So you have to do this. It might help you to do a little box here. The first 4 terms. So you've got term number 1, term number 2, term number 3, term number 4. These are what you put in for the letter n. So you put 1 in for the letter n, 1 minus 1 is 0,
Yeah,
and 0 times 2 is 0.
I just multiplied 2 and n each time.
2 minus
instead of
1,
doing
yeah.
parentheses first. Okay, I've heard nothing you, Calvin, for the time being.
Wow, this is starting to get serious, Calvin.
Calvin.
Looking at, let me just go with which one I saw the most issues with first, and then we'll work our way from there. Problem number 15, apparently,
Yeah.
there were a few issues there.
I got 15.
I got 15.
Take a look at this one, please. Let me give you, well, I don't know. Let me just throw this at you because you're 8th grade and you should be smart enough to realize this. What gives most people problems, number 1 is the negative, number 2 is probably the fractions. You can always get rid of fractions by multiplying everything by the least common multiple of the denominator. If you were adding these fractions together, what would be the common denominator? 12. If you multiply, let's do this, negative 3/4 plus 2/3 x equals 1/12. If I were to multiply all 3 of those by 12, you can easily rid yourself of the biggest headache, which is the fractions. Since 4 goes into 12 3 times, 3 times 3 is a negative 9. 3 goes into 4 4 times, 4 times 2 is 8, plus 8x, x was there, plus was there, and 12 goes into 12 once, so you end up with a 1 over here. This is the same equation as that, you'll get the same answer. Really all you have to do is add 9 to move it over here, add 9, so you end up with 8x equals 10, divide by 8, divide by 8, that's your answer, reduce it. By force is fine, if you like 1 1/4 would be fine as well. You can still do it as fractions, it's going to work out the same way. You would just add 3/4, which is how many 12s? 9 12s plus 1 12 is 10 12s. That equals this. 2/3 x. How do I get rid of the fraction? Flip it and multiply. Multiply by 2/2. Cross canceling, this goes into that 1 time, then 5 times 1, 4. You still get 5/4. Either way. It's just that this way you don't have to deal with fractions quite as much. And that really wasn't a bad fraction problem there, as it would be. Ev?
For 15, I got 4/5.
Okay, you were
I don't
wrong.
know where I went.
Did you flip the wrong fraction? You always flip the one next to the x.
Yeah, I probably,
You probably did. So there would be something I would
I
write.
did.
There would be what I'd write on tomorrow's notes. Make sure you flip the correct fraction there. How many people miss 0? 1? 2? You didn't even do it.
Yeah.
So it's
3
zero.
problems? 4 problems?
Oh,
3.
Wait, I haven't
One,
counted.
three.
Oh, wait, what's this?
4, 5.
Smith, which one was your question?
Number 5.
Number 5.
I missed 3.
Find the
Yeah,
volume
how
of the cone in question 4. Express terms of pi. On your notes, please write volume of a cone. I'll put V little c there because that means volume of cone. It is the same thing as the volume of a cylinder, which is pi times radius times height. That's the volume of a cylinder, but a cone comes to a point, and anything that comes to a point we divide by 3. I don't even know what that cone looks like, but I'm gonna see if I can't figure out the dimensions. What was the radius of the cone? We have it over there, do I have to look?
3.
Did it tell me the diameter was 6?
Yeah.
So it probably did this and said this was 6.
Yeah.
So the radius is half of that, which is 3. Did we have to find the height? The height of the cone,
was there.
It's 4.
the height has to be perpendicular to the base. Either they'll put it as a line like this with a square, or they'll give it up here. That was 4. So there's all you need to find this. It's pi times 3 times 3 times 4, all divided by 3. And since you got a bunch of 3's on top and 1 3 on the bottom, just cross off 1 3 with 1 3. 3 times 4 is 12, and you still have the little pi there. Whatever it was, inches cubed, units cubed, inches cubed.
So it's just, I got this wrong. I got 6 pi.
Well, you can multiply 3 times 3 and get 9, times 4 is 36, but divide 36 by 3, you're still gonna get 12.
Yeah, that's what I did.
There's no way, I mean, you're not gonna get, I don't know how you get 6.
I don't either. I divided 23, or 24.
Did you add 3 plus 3 to get 6 and then multiply by 4? This is all multiplication. Again, notes to self on tomorrow's. Please don't do the same mistake twice, because that's each one is worth a half a grade. So Christine?
Number 2.
Crazy. Number 2. Oh, by the way, somebody needs to talk to me about number 3. Last year, Sheldon used 50 feet of fencing to enclose a rectangular garden with an area of 150 feet. This year, Sheldon plans to use 100 feet of fencing to enclose the garden and similar in shape. What will be the area of the garden? Okay. Again, people, hopefully you can read through this problem. This problem is a scale factor problem. Okay, you can save yourself a lot of work and a lot of time just by thinking that. You draw the first one, you know its perimeter is 50. You draw the second one, you know its perimeter is 100. That means it has a scale factor of 2. What do you multiply this by to get that? Your scale factor is 2. It tells you that the area of the small one is 150 feet squared. You don't need to know any dimensions on this, because if you know the area of the small one and you know the scale factor, how do I find the area of the big one? Well, this is area. What do you do to scale factor to get new area? When you talk about area and scale factor, you have to square the scale factor. So if I square, scale factor squared, if I take 2 and square it, I get 4. The area of the new one is 4 times bigger. If it was B volume, it would be 8 times bigger because that's scale factor cubed. Ooh, 4 times 150 is 600 feet squared. You don't need to know any dimensions other than that scale factor doubles. G-rays.
Can you show me the answers to number
I will gladly show you the answers right here. Don't look at the answers for tomorrow. What is it, 20A? So that was 20. I am going to do number 3 because, just because here. Number 3, children, it's kind of tough to read through, but again, number 3 is a inverse variation problem. Inverse variation, which means this. If you take speed and multiply it by time, okay, you're going to get this constant over here, which actually is distance. Speed times time is distance, which only makes sense. But forget about the problem, just think about this. If your speed is going 20 miles an hour, and you drive for 5 hours, how far did you go? 100 miles. Well, if you increase your speed to 50 miles an hour, to go the same distance, what has to happen to your time? It goes down. Okay? As one goes up, the other one goes down, which is the same thing with this. His speed was 4 miles per hour, and the time was 15 minutes. So that equals 60. So everything here, when you multiply, as long as you keep time in minutes, okay, don't put it in hours, because you have to be consistent with your units of measurement. The speed now went to 10 miles an hour. Okay, you don't know the time, but you still had to go 60. So 10 times what number gives you 60? 6, and that was the time. It would take you 6 minutes going at 10 miles an hour. If you were going 15 miles an hour, it would take you 4. If you were going 60 miles an hour, it would take you 1 minute. If you were going 0 miles an hour, it would take you, you can't do it. Impossible, yeah. And that's why the graph of whatever inverse variation never crosses that. So note to self, just make this inverse variation. You can't really go too wrong as it would be. Loops! 16? 16? 6. The lateral surface area of this right pyramid with a square base. Here again, here is going to be your formula. The lateral surface area of a pyramid. That's my little, I'm going to put that little P down there. Okay, because these are triangles, children, you're going to use the triangle formula. That's why triangles always get cut in half. You are going to take the perimeter of the base, you will then multiply that by the height. Actually, it's a slant height. Should I write that out? Do we have a letter we specifically use for slant height? Yeah, S stands for side though. L actually is slant height. I'm just going to write slant height. But since it's a triangle, and with triangles you always cut those things in half, divided by 2. So this bottom, even though it didn't copy very well, is a square. It's 6. The perimeter of the square is 6 plus 6 plus 6 plus 6, which happens to be 24. The slant height, which would be, wait, could you see the slant height?
Yes, but
Did it show up on the paper?
a little bit.
Okay, it was hard to see. Tomorrow, make sure I'll tell you what it is. The slant height was 5, and then you're just going to cut that in half, which means you could cut 24 in half and get 12. And 12 times 5 is going to be the 60, whatever, inches cubed, whatever units. You could, by the way, if you didn't like the formula, you could find the area of each one of these triangles and add them all together. They're all identical triangles, so you can find the area of one triangle and multiply it by 4. Doesn't really matter. This would be the formula if it was a goofy looking rectangle. Note to self, Sammy Spaniel.
What was the answer for number 4?
Grace, what was the answer to 4? Oh, sure, thanks for closing the book.
Oh, Grace.
Number 4, somebody knows the answer, what is it? 5 inches.
5 inches.
You want me to do that one?
Calvin.
Let's do number 4. Get to this side. Number 4 says what is its height? Oh, yeah. Anytime you're asked for the height of a cone and they don't give it to you, wait, they give you the height. You know this. Here, let me show you. We talked about this before. This 4 inches is the same 4 inches if you drew this line right down the middle to the middle and made a right triangle out of it. You know that the height of that triangle, or one of the legs, is 4. You know that from here to here is the radius, so that's half of that. This is 3. You are just looking for the slant height, correct?
Yes.
Well, there's your right triangle. You're hoping it's a triple. There is a 3, 4, 5 triangle. If it wasn't a triple, you would have to do the whole Pythagorean theorem out. A squared equals B squared equals C squared. Okay. But if they're asking you for the slant height, that's really the only way to do it. You got to think of that right triangle that gets made right there. A, B, C. G-race.
What was 18?
Wait,
Yeah.
didn't that give me the answer, Buck?
We're confused.
For 18? 0.06 or 3/50ths.
Let's see.
You want me to do it?
No, I got it.
Wait, what was confusing about it?
I don't know, the answer.
Mostly people, when you see these, if you come up with 66 2/3% or 11 1/9%, there is no other way to do these except by making everything fractions, because sometimes percents don't work out evenly as decimals. I mean, if I made this a decimal, it would have to be 0.3 repeater, and there's no way to deal with 0.3 repeater, as this would be 0.6 repeater. You can't do that. You have to make this 1/3, you have to make this 2/3, and make this 27/100. The only way to get super accurate there, because repeating decimals, you can only get close and you can't get it right down the money there. Christine?
Number 8.
8? Did we do 8? Oh, yeah. The area of this rectangle, Christine, which is what? Length times width, right? Length is 2 times the square root of 2. You're multiplying that by the width, which is the square root of 2. What is the square root of 2 times the square root of 2? The square root of 4. What is the square root of 4? 2. And then 2 times 2, because you still have this 2 out there, is 4. Did I not do it right?
Try to do the square root of 4.
The square root of 2 times the square root of 2 is the square root of 4.
But the square root, it's like when you have 2 square roots that are the same, they cross off. Like,
Yeah, I know.
You could write it out like this, Christine. This is 2 times the square root of 2, and you're multiplying that times the square root of 2. 2 identical square roots of 2 give you a normal 2, and then 2 times 2 is.
I was just like,
Yeah, I was thinking of that.
Lutz,
number 1.
number 1.
Right?
Number 1, ladies and gentlemen, you know, this is all kind of, you're at the point here where you can do this a couple different ways. Alexa, if you go into the store and buy, if there's a big sign that says 20% off, how would you find out how much you have to pay for that thing?
Google.
That's Siri.
Probably work. Siri? I wonder what would happen if you did that.
Siri's not helpful.
How much is? This is probably, Alexa, this is probably how you should do it. Make a percent box. Hopefully you're getting to the point though where you don't need the percent box and you can kind of see this happening in your head. If it's a discount problem, here's your percentages. Your original percent is 100%. The discount is 20%. So you're actually going to pay 80%. Okay, that's how much of the thing you're going to actually pay. The original price was $4.95. The discount we don't know. We're looking for the final price, so you're looking for this one. So the fraction you're looking for is, or the ratio is 100 over 80 equals 495 over what number? And you could reduce this all the way down to what?
5/4.
Yeah, 5/4. So multiply by 4, divide by 5. Or, people, quicker, simpler, you know you're going to pay 80% of the price. So you just, if you take 0.8 times this, you're going to get the answer. Because you're paying 80% of the price. Or, you're getting 20% off, so multiply by 0.2 and subtract it. That's the same thing. You don't have to do this, but sometimes this helps people who kind of struggle with that. Okay, you're paying 80%, you're getting 20% off, 0.2 times that. 0.2 times that would be what, 99?
Yeah, there, subtract 495.
$99 is 0.2, yeah, subtract that.
Yeah, 365.
I mean, if your way is working for you, you certainly don't have to do this, but this just kind of organizes things if you struggle with that. If Siri is not that close to you. Kelsey?
I don't get how I got number 9.
Yeah, number 9's not so bad. If you jot notes, I'm pretty sure you'll get it right. Becky is thinking of two numbers. Their sum is 10 and their difference is 6. What are the two numbers? Okay, if you're thinking of two numbers, they're not the same number. Well, I don't think they're the same numbers. Okay, you just have to identify what your variables are, and they would be like this. X is one number, and Y is the other. Their sum is 10, so X plus Y equals 10. Their difference, which is subtracting, their difference is 6. That's the other equation. And really the only way right now for you to do it, we'll do this differently later on, is to graph those and see where those two lines cross. If you are graphing it, this is what that would look like. And those are easy ones to graph because they're both standard form and they're real easy. X and Y here both would be 10, correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Crosses there at 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Crosses there at 10. The line goes like this. The other one, here's where you have to be a little careful. It's kind of the same deal, except X is 6. 1, 2, 3, 4, 5, 6. But Y has a negative in front of it, so Y is negative 6. 1, 2, 3, 4, 5, 6. Graph those two lines. The place where they cross, which happens to be at 8, 1, 2, mine's a little off because I did a freehand, is the answer to both. Is 8 plus 2 10? Yes. Is 8 minus 2 6? Yes. Now some of you probably did that in your head, but I will look for the graph because it says to graph it, so don't just do it mentally.
I did graph it.
Don't get it when you can't.
No, I didn't. I actually did it last night.
Dude, what the heck?
Erase.
I don't understand
Number 11. What two numbers are the solution of that equation? You have 3x squared plus 6 equals 81. How do I solve that for x, Grace?
You subtract 6.
I do subtract 6, which gives me 75. Now I have 3x squared equals 75. Now what?
I
Divide by 3. Divide by 3. So here's the deal. X squared equals 25. And that's asking you what number times itself gives you 25, or x equals the square root of 25. And remember, every time there's a square root, there are two answers. What number times itself gives you 25? Both positive 5 times positive 5 gives you 25, but so does negative 5 times negative 5. So the answer is plus or minus 5. Positive 5 or negative 5. If you have your, I'll let you use your whatever sets of numbers thing there if you need to. Christine?
Number 19.
Number 19. For number 19, Mrs. Stone.
You, switch potential thing, you should explain.
Absolutely.
Awesome, thanks.
I did.
Yes, but she didn't. Thanks for reminding me.
We switch Wednesdays. We switch Wednesdays.
Did have yesterday.
First
it's the
yeah, so the first Wednesday of the month is what's assigned, second Wednesday.
Wait, they figured out there's a pattern.
No time,
One
very
Wednesday.
great.
Wait, what? I still
I've only done this now for 4 years.
Well, I don't get to
Take
take
No.
I
thought they gave it.
Alright, problem number 19, boys and girls. Please know the last thing you're gonna deal with is that negative 1 on the bottom, so you have to simplify the top. When you simplify the top, there are 1, 2, 3 parts to that top. You need to simplify each one of those and then add them or subtract or combine them, I guess. Negative 5, there's no reason for those parentheses, it is just a negative 5. Here you have a negative 4 times a positive 3, which is a negative 12. And here you have a negative 2, which turns into a positive 2, two negatives next to each other. Then you just put those 3 numbers together. A negative 5 and a negative 12 gives you a big negative, negative 17. Negative 17 plus 2 is a negative 15. Okay, that was addition. Now we're back to multiplication and division. So 2 negatives there are going to give me positive 15. And again, why didn't I do this multiplication first? Because a fraction line is like a parenthesis. It's a grouping symbol. You should think of this like this. You have to simplify all that before you divide by negative 1. Sam? 17, my favorite of all problems. Let's just get the numbers out of the way first. 2 goes into 6 3 times, so the 3 ends up being up there. I want to make negative exponents positive, so I'm going to take this x with its negative 1, move it to the bottom so it becomes a positive 1. And it doesn't matter how you think about this. Let's do the y first. If you have a y squared on top, divided by 1y on the bottom, okay, there's 2 y's up there, one on that 1 crosses off with one of the 2 up there to leave you with just the 1 on top. On the bottom you have 2 x's and there's 3 on top, so those 2 will cross off 2 of the 3 and leave you with just 1 y on top, or x, I'm sorry, on top. So we write letters alphabetically, so that's why the answer was given as 3xy.
Oh.
It doesn't matter, 3yx is the same thing. For consistency's sake, we try to do it alphabetically. Change.
Number 20.
20. 0.2 minus 0.02 over 0.2 times 0.02. Again, multiplication on the bottom, addition, subtraction on the top. Christine, did you get this on top? 0.2 minus 0.02. Line up the decimals, you end up with 0.18 on the top. 20 cents minus 2 cents is 18 cents. On the bottom, this is multiplication. 0.2 times 0.02 is 4 with 3 decimals, so you have to back up 3 places. On the bottom, you get 0.004. You want me to do that again slowly? And then you have to divide 0.004 into 0.18. Move the decimal 3 places. 3 places is the same thing as 4 into 18. Did it leave it in fraction form? I don't know. No. Because 4 goes into 18 4 times, that's 16. 4 goes into 25 times 45. 4.
I did 2 times 2
Lutz. 16. Alexa, did you do the distributive property here? Simplify both sides first, so that means you need to get rid of that parenthesis by expanding, multiplying 5 times x and then 5 times minus 2. So 5x minus 10 equals x plus 6. Did you do that? How could you even do it without doing that?
I like combined all these numbers.
But you can't combine these, they're in parentheses and those aren't in parentheses. Then once you simplify each side, you move your x's to one side by adding and subtracting. So I'm going to subtract this x from both sides, which is my subtraction property of equality. Which means you get 4x minus 10 equals 6. Now I move the 10 to the other side, so I add 10. Add 10 to 6. Now I'm left with 4x equals 16. Divide by 4. Divide by 4. X equals 4. Emma Bruel.
Number 7.
Have we, there was some we haven't done yet? Oh yeah, number 10. Please note, because I don't know if on the test tomorrow it's going to be an and or an or inequality. If they're grouped together like this, it is an and one, which means the line comes together from the dot. If it's an or one, you will see the word or and the lines go in opposite direction. This one is an and. You read it like this: x is greater than and or equal to -3 and x is less than 2. It's not a hard thing. At -3, because of this equal sign, it's colored in. At 2, since it's not equal to, it's an open circle. And since it's an and, you color in between the two. If it would have been an or problem, the lines would have shot off and not been colored in the middle. Wow. Let it be duly noted on the thing, parents, if you're watching, that Evan and Calvin have been having a good time through the entire class. Christine, kind of too, also joined in with Calvin. Guilty mostly by
I'm
association.
happy that I
Way
got it right.
opposite.
Christine, way off for the court.
Way opposite. I'm having a terrible
Alright, Smith says just because we have a little time, let's finish it off with 12, 13, and 14. But this should not be too tough for you. Please note, a binomial times a binomial, we do our favorite little FOIL thing, which means you take the first terms, which x times x is x squared. The outside and the inside terms are going to combine. You will put them together. Outside is 3x, inside is 3x. 3x's and another 3x's give you the grand total of 6x's. And then your last term comes from the two last. 3 times 3 is 9. Two binomials that give you a trinomial. Remember, if the binomials are the same except one's plus, one's minus, it would look just like this except no middle term. The middle term goes away because one's plus 3x, one's minus 3x, they're gone. 13, again, you hopefully have your little sheet there. Integers, which are positive and negative whole numbers, is a subset, which means it is combined in the set of rational numbers, which are combined in the set of real numbers. But rationals is your only choice. Whole numbers are integers, but only positive whole integers. And counting numbers are the whole numbers, except you don't include the number 0. Because when your parents taught you to count, odds are they didn't start with 0. Because you've got no 0 fingers. How could they have done that?
You don't know how long your fingers.
I feel like my dad.
Amputated your fingers would have been the best.
Travel top.
And relationships being proportional.
What's with the big, yeah, what's with the huge? What's with the huge?
That's my note. This was an 8th grade thing, because when I
Oh.
can't tell. In order for something to be proportional, two things have to be true. It has to go through the origin, so when the first thing is nothing, the second thing is nothing. And they need to be a straight line when you graph it. So you look at these and say to yourself, time worked and money earned. If you work 0 amount of time, do you get $0? Yes. You don't get paid for not working, so you know it goes to the origin. Is every time you work, if you make a table out of this, 1 hour is 12, 2 hours is 24, will that be a straight line? Actually, it will. Side length and perimeter of a square, you probably would have to do a couple examples of that. First of all, is the side length 0, would the perimeter of the square be 0? Yes, because you would have no side, so that fits that. Okay. Let's say is it a square? So do the math here. If the side length was 1, we're making a table, x and y. Side length is 1. What's going to be the perimeter of the square? 4. If the side length is 2, what's the perimeter of the square? 8. Now here's where you stop, because in order for something to be a straight line, it has to have the same constant. In other words, 1 times 4, to get 1 times this, you multiply by 4. Get 1 times 4, wait, are we doing the right one here? Yes. If it's 3, what would 3 be? 12. So shouldn't this be, isn't this proportional too? Does it say which one they're not? Oh, that makes sense. I was reading the wrong problem. Those are both proportional. Driving distance traveled at 45 miles per hour. Time, distance. If you travel 0 miles, will you go, or 0 time, will you go 0 miles? Yes. 1 hour, you'll go how far? 45. 2 hours, you'll go 90. Are these all proportional? Do you multiply by the same thing every time? Again, proportional. I'm hoping D is the answer to this. The side length and area of a square. This time it's area, it's not perimeter. So let's do this. Side area. If you have a side length of 1, what's its area? 1 times 1 is 1. If it's 0, do you get 0 for area? Yes. If it's 2, 2 times 2 is, and you can stop there because to go from 1 to 1 you multiply by 1, which means you'd have to multiply everything by 1. This one you multiply by 2. This one is not proportional. And that's it, ladies. Go, gentlemen, go. U.S. history and